Here in this video, I would like to derive an equation for internal resistance of a discharging cell. You know, a cell has certain kind of an EMF which is being represented like this, with a positive plate of a battery and a negative plate of a battery. It is now connected to an external resistance, and this cell helps pushing up of the charges because of its energy. But this cell will also have some opposition inside, which is called as internal resistance. We have derived an expression, or else we have explained about it in the other videos. Now I want to calculate what is the value of that internal resistance itself. So this current I will go through this external resistance and then come to this internal resistance and come to the negative plate of the battery, and that will be keep on happening. So the first point that we need to understand is internal resistance of the cell acts like a series resistance to the external resistance. Acts like a series resistance. So this cell must be having some EMF. Let that EMF is equal to E. That E will, because of that E, the current will pass. As these two resistors are in series, there will be voltage drops across them. The current is same in series, but the voltage drop will be different. That the voltage drop across this is V. You can say V1 otherwise. Voltage drop across the internal resistance is V2. Then we can say the total E can be written like V1 plus V2. So total E, let me call this V1 as a potential drop in external resistance as V itself. V2 is the, as per the Ohm's law, IR, where I is the total current that is passing in the circuit. R is the internal resistance of that cell. So we can further simplify this. E minus V is IR. So I can write a formula further for say resistance, internal resistance, that is E minus V by I. So what is the value of that I in the circuit? We know the total current in any of that circuit can be written like as per the Ohm's law, total voltage equal to total current and total resistance. Total voltage is E in the circuit. Total I is the I want to calculate. Total resistance is sum of these two resistors which are connected in series. We know in series total resistance is R1 plus R2. So in the place of I can write E by capital R plus small r. So the value of that internal resistance could be E, value of that internal resistance could be, I'll just use this formula. E minus V by I. What's the value of that I we have calculated just now? E by capital R plus small r. So if you rearrange the terms, E minus V by E and R plus R. So I have to simplify this further. How I can simplify is, I will rearrange the terms. Yeah. How I will rearrange the terms is, capital R plus small r of the right hand side, I will use that side itself. I'll get this small r to this side, and I'll take this entire term to the other side. It will become E by E minus V. I have just rearranged the terms. So if I simplify this further, E by E minus V will be capital R plus small r by R. So, well, let us simplify this further. That implies E by E minus V. I am just writing this. I will divide with R in the other term. for each of the term. That's capital R by small r plus small r by small r. So E by E minus V is capital R by small r, and small r by small r is equal to 1. So let me get that 1 to the other side of the equation. E by E minus V minus 1 is equal to capital R by small r. Let me take the LCM. E minus V, then it becomes E minus E plus V equal to capital R by small r. So these two E's will get cancelled. V by E minus V is capital R by small r. So if I reverse that, small r by capital R is E minus V by V. Small r is equal to E minus V by V into capital R. Yes, that's the formula. So the internal resistance of a discharging cell is total EMF supplied by the battery minus potential drop across the external resistance by potential drop across the external resistance multiplied by the external resistance itself, right? Of course, if the cell is an ideal cell, for an ideal cell, potential drop across the cell is nothing but equal to the EMF itself, then it becomes 0 itself. That kind of a cell is called an ideal cell. That's how we can derive an equation for the internal resistance of a discharging cell that is connected in a circuit. Thank you for watching.